Okay, good morning, all of you. I hope students are still okay. So, what we'll do, we'll solve some questions based on composite functions or partial differentiation. The first one is given if x is equal to root of VW, y is equal to root of W into U, and z is equal to root of U into V. Then prove that x into del phi del x plus y into del phi plus z into del phi del z is equal to u into del phi del v plus v into del phi del v plus w into del phi del w, where phi is a function of x, y, and z. So first of all, let us see the tree diagram. So then it will be clear basically from where we need to start. So what is given here that phi is a function of x, y, z, and x, y, z, they are functions of u, v, w. So that now if you want to draw the tree diagram, then you can draw phi function of x, y, z, and these x, y, z all should be a function of u, v, w. Then only we can get the composite function. So this means that x, y, z, they are all functions of u, v, w. So then we can say that phi is a composite function of u, v, and w. Okay, so phi is a composite function of u, v, and w. So therefore, now we know what we need to find. We need to find del phi del u, then we need to find del phi del v, and we need to find del phi del w. So before we, see what we need to prove, so at least let us find out what we can find. So for del phi del u, so to come to u, so we have to use all the possibility or all possible paths that lead to. So that means what we will get now del phi. So first we'll have to differentiate with respect to x, and here you can see phi is a function of x, y, z, so more than one variable. Similarly, x, y, z are functions of u, v, w, so more than one variable. So everywhere it will be partial derivative. So del phi del x and then x with respect to u. So it will be del x del u plus. Next, to reach to u, we also have, phi, y, and then y to u. So it will be del phi del y and then del y del plus del phi del z and then del z del u. So I hope this is clear. Now from here we'll find out whatever we can find. Now del phi del x. Your phi is given as phi is a just function of x, y, z. So what function we don't know. So therefore del phi del x will be as u. And del x del u, your x is given to be what? Root of vw. So if x is root of vw, then del x del u, so there is no u. That means u power is 0 here. So del x del u will be equal to 0 plus del phi del y. Similarly, phi with respect to y, we don't know, so we will write it as del phi del y and del y del u. So what will be del y del u? So in this case, for y, you can see we have root w and root u. So root w will behave as a constant when you are differentiating with respect to u. So root of u differentiation is what? 1 by 2 root u. So it will be 1 by 2 root u into root w plus del phi del z into del z del u. Now for z with respect to u, so it will be 1 upon 2 root u into root. So this is what we have got for del phi del u. Similarly, now we'll find for del phi del v and del phi del w. So for v, we have to consider all possible paths that lead to v. So first it will be del phi del x and then x with respect to v. Then phi with respect to y and then y with respect to v. And phi with respect to z and then z with respect to. So which is equal to now del phi del x into del x del v. So here there is v, but root w is there, so root w is constant. So 1 upon 2 root v plus del phi del y into now y with respect to v. There's no v, so it has 0. Then we have del phi del z into del z del v. So del z del v is root u upon 1 upon 2. So the last one, and you should not write all these similarly, okay? So you are supposed to write down first the formula and then you are supposed to show the value. So del phi del x, x with respect to w, then phi with respect to y, and then y with respect to w, plus phi with respect to z, and then z with respect to w. So del phi del x into now del x del w. So here root constant. So 1 by 2 root w. Next we will get del phi del y and then y with respect to w. So y with respect to w, u is constant and 1 upon 2 w. Then we have del phi del z and then z with respect to w, that is equal to. Now we'll see what we need to find out. So in the question, what is given? So here you can see we have evaluated del phi del u, del phi del v, and del phi del w. So now we'll see in the question where all these terms are there. So if you see the question, so these terms are there on the right hand side. But on the right hand side, along with del phi del u, u is multiplied. Along with del phi del v, v is multiplied. And with del phi del w, w is multiplied. So that means we need to start from what here? Right hand side. Okay. So now let us come to right hand side. So right hand side is equal to u into del phi del u plus v into del phi del v plus w into del phi del w. So now let us write it. So here what you can do, because we are supposed to first multiply with u, v, w respectively, and then we are supposed to add. So if we are adding, in that case del phi del x is common, right? So you will be basically adding these values along with multiplication of u, v, w respectively. So what we can do now, directly we can now consider del phi del x, let us say common, then u into 0 is 0 plus v into this, that means we will get half into root of vw. Next we will get from here, we are multiplying by w, so 1 upon 2 root of vw. Oh, sorry, we are multiplying by u, sorry. sorry, here u, then here v, and here w. Yeah. So here we will get v, say, so root of vw, and here we will get w, say, correct. So root of vw. So this is what we are getting. Next, what we will get plus del phi del y. So let us multiply this one with u. So we'll get half under root uw plus next this is 0. And here we are multiplying by w, so it is half root uw. Next we will be adding up del phi del z, and with del phi del z, this is we are multiplying by u, so it is half of uv plus next this we are multiplying by v, so half uv, and the third one is okay. So which implies which is equal to now half plus half 1, and then root vw. Okay, so root vw del phi del x plus next we will be getting with this root uw del phi del y plus, and here we will be getting root uv del phi del z. But vw is what? Vw root vw is x. So this we can write as x del phi del x plus uw is y. So y del phi del y plus, and root uv is z, so it is z del phi del z, which is equal to 6. Is this clear? And what happens when you write, one below the other? Below. Yeah.
No, I forgot what I wanted to ask again. Sorry.
Oh. So when you actually write, one below the other, then this addition, subtraction, this becomes very easy. So you can, easily you can see. So this plus this plus this, that means here you can see del phi del x is common. So take common del phi del x, and then whatever is required. So u into this, v into this, w into this. So that way it becomes, easy for us to determine what exactly we. Okay, so I hope this is clear. Now, next we want to find this is done. If u is equal to f of r and r square is equal to x square plus y square plus z square, then del square u del x square plus del square u del y square plus del square u del z square is equal to f dash of r plus 2 by r f, sorry, this is f double dash, f dash of r. Here we are going for the second order partial derivative. So u is equal to f of r square is equal to x square plus y square plus z square. Then we need to find this. And if you notice here, this value or the answer we want in terms of r, not in terms of x, y. So let us start with first with to find this. Okay, so u is equal to f of r, and r is a function of x, y, and z. So if we draw the tree diagram, then it will be like u is a function of r, and r is a function of x, y, z. So this is of the first type that we have done. So u is a composite function of x, y, and z. So that means what we need to find del u del x. So what will be del u del x? So del u del x will be equal to u is a function of only r. So that means here we will be getting what? Du dr, and then r is the function of x, y, z. So it will be del r del x. Now, u is what? F of r. So, ddr of f of r is nothing but what? F dash of r. But what is del r del x? That we need to find out. So, let us write here first del r del x, and then let
Ma'am,
us now
just want to understand why did you take du by dr?
because here u is a function of one variable r. The moment it is a function of single variable, then we don't take partial derivative, then we take total derivative, right? And whenever it is more than one variable, if the function is depending on more than one variable, that times we need to consider partial derivative.
Okay.
That's why this tree diagram helps us to write. Okay. So what basically it will be. So now we don't know what is del r del. So first let us find out what is del r del. So what we have here, r square is equal to x square plus y square plus z square. Now r is a function of x, y, z. Fine. So that means this both sides we can differentiate with respect to x as well as y and z. So now let us differentiate both sides with respect to x. So then what we will get, 2r del x is equal to, which implies del r del x is equal to x upon r. Now, here x square, y square, z square, they all are added and they are all, you can see that this is only function of x. This, if you consider this as 1. So here we have only y. There is no z terms or x terms. And for this term, there is only z. So therefore, whenever we will be finding, okay, del r del y or del r del z, it will be exactly similar to this one. Only difference will be in place of x, it will be y and z. So therefore, here, due to this symmetry, we can write similarly, del r del y will be equal to y upon r, and del r del z is equal to z upon r. I hope this is clear. So therefore, now we can write del u del x is equal to f dash of r into del r del x is x upon r. Now here we can write this as f dash of r by r, that is, this is fully function of r alone into. Okay. Now next, what we will find, we will go for the second derivative, del square u del x square. Because as you know, there is a similarity, so therefore del u del y as well as del u del z will be exactly similar to this. Only difference will be what? That in place of x it will be y or z. So therefore we will not evaluate each one here separately. We'll simply find del u del x and then directly we will go for del square u del x square, and then we will write these two looking at this del square u del x square. But this thing for all problems you can't do. You can do only when there is a similarity or symmetry is there. Okay, so now let us find del square u del x square. Now del square u del x square means what? Del x of del u del x. But what is my del u del x? Del x of del u del x is f dash of r by r into x. Okay? Now here what we will do, we will apply UV rule. Now for u, it is a function of r. Okay, so if I consider this is my new u, okay, so UV rule I will apply. Now for my new u, so it's the same thing, right? U is a function of r and r is a function of x, y, z. That means for this particular, function, for this particular term, I'm going to apply exactly the same thing when I'm differentiating with respect to x. That means first we will be differentiating with respect to r, and then that r we have to differentiate with respect to x. So this one now, if we differentiate with respect to r, so what we will get? R square, then r into differentiation of first function, so f double dash of r minus f dash of r into differentiation of r is 1 into del r del. Okay, and then this b is still there, so it is x. So this is my u dash into v. That is what I have done. Plus next f dash of r upon r, and then this one now we have to differentiate with respect to x, and that is equal to 1. So what I have got finally, r f double dash of r minus f dash of r by r square into del r del x into x. Now what I can do, del r del x, again I can substitute with this x by r. So then what I will get, so therefore which implies r into f double dash of r minus, or if you want you can also simplify this, so then you can write this as f double dash of r by r minus f dash of r by r square. Okay, this is in bracket. Then del r del x, del r del x is x by r into x, plus this term is there, so f dash of r by r. Okay. So what finally we will be getting here, so this is equal to f double dash of r by r minus f dash of r by r square into x square by r plus f double dash of r by. So you can see in del square u del x square, only one term is in terms of x, rest all are in terms of r. That means if we do del square u del y square, then only x will be replaced by y, and the remaining term we will get as it is. Hence, now we can write, therefore we can write similarly. So let us write del square u del y square will be equal to f double dash of r by r minus f dash of r by r square into y square by r plus f dash of r by r. Similarly, we can write del square u del z square is equal to f double dash of r by r minus f dash of r by r square into z square by r plus f dash of r by r. Now, coming to the left hand side. So now, left hand side means del square u del square plus del square u del y square plus del square u del z square. So now if you see, only difference is there in the first term. If you consider from each one, this term is same, right? Also divided by r, that term is same. So we can take basically common f double dash of r by r minus f dash of r by r square. This we can take common, and then 1 by r also we can take common, and we can write here x square plus y square plus, and the next, all the three terms are same, so adding this, so we will get 3 times f dash of r by r. Now, what is x square plus y square plus z square? X square plus y square plus z square is nothing but r square. So therefore, we can substitute this as r square. Then we will get f double dash of r by r minus f dash of r by r square. And here what we will get, 1 upon r into r square plus 3 times f dash of r by r, which is equal to, now here we have 1 r, now simplify it, so f double dash of r minus f dash of r by r plus 3 times f dash of plus 3 times f dash of r by r. So which is equal to f double dash of r plus 2 times f dash of r by, so which is equal to, right? This is what we want to. The only thing is that you should not consider at any given point that R is not a function of x, y, z. Okay? So many times, there students do the mistake. So first, when you are finding del R, del U, del X or del U, del Y, so that part usually everybody does correctly. But then later on, when you go for the second order derivatives, then don't get confused that this is constant. Okay? So that is also a function of R, and therefore this tree diagram always helps us. This is one of the important
Yes,
and
ma'am.
all these questions are there in the practice questions. Okay, so you can check this. So this is the third one. So here we have if z is equal to x into log of x plus r minus r and r square is equal to x square plus y square, then prove that del square z del x square plus del square z del y square is equal to 1 upon x plus r one upon x plus r. Del square z del x square plus del square z del y square is equal to 1 upon x plus r. So, and all these involve, second order derivatives. So this will contain at least 7 marks. It won't be for 8 marks, but definitely for 7. Okay, so now here you can see there's no similarity, x, y. So therefore, we'll have to evaluate both separately. So this is also similar. So z is a function of, r basically, x and r, but then r again is a function of x and y. So ultimately, z is a function of x. You can say z is a function of r, and then r is a function of y. So basically, when you draw the tree diagram, so it actually shows like this. That is a function of x, and then here r, and then r again function of x. So ultimately, it becomes composite function of x and y. So that means we need to find del z del x as well as del z del y. So now let us see what will be del z del x. Now, as you can see in this previous question, that whenever we have this type, like u is a function of r and then r is a function of x, y, z, then it's always better to first find del r del s del r del y del r del z. So before we start, we will find out first here what will be del r del x and del r del y. So differentiate with respect to x. So we'll get 2r del r del x is equal to x. So therefore del r del x is equal to x by r. Now here we can use similarly because it is symmetric. So similarly we can write del r del y is equal to y by r. Yes. Now we'll find del z del x. So now for del z del x, let us see what is our z. That is x into log of x plus r. So there we have to use what? UV rule, because that is a function of x, that is a function of r. So if we apply UV rule, what we will get? Log of x plus r plus x into differentiation of log of x plus r, that is 1 upon x plus r. Then we are differentiating x plus r with respect to x. So x with respect to x is 1, and then we got r with respect to x. So let us write this first, del r, del x. Then we have your minus r. So for that also we will be getting del r, del x. Now let us substitute the value. So log of x plus r plus x by x plus r into 1 plus del r del x is x by r minus x by r. Now this let us simplify. What we will get then? Log of x plus r plus x by x plus r into r, and then here we will get x plus r minus x by r. So this x plus r cancel, and then we have x by r minus x by r, so which is equal to log of x plus r. So del z del x is equal to what? Log of x plus r. Now next we will find the second order. So del square z del x square. Now here
Ma'am.
what we are doing? हाँ बोलो.
Ma'am, in the first line of the right side, why did you take x into 1 by x plus r? Because you took the partial differentiation of log x plus r.
Correct. Log x plus r.
तो
Log
उसका
of
तो
x plus
बनता है
r with respect to x.
okay.
Yeah, because here you can see we are differentiating with respect to x, right? So log function का this function of the function ना, so log का जो है वो log का क्या रहेगा? 1 upon whatever you have log t, तो फिर वो 1 upon t आएगा, right? फिर हम देखते हैं वो t क्या है, and then वो t को हम differentiate करते हैं, correct? That is what we have been doing, right? So यहाँ पे log of x plus r है, so log function का हमें differentiation तो करना ही है, तो उसका हो जाएगा 1 upon x plus r. So basically we are considering this as one variable. If we consider suppose this is as t, so then what we will get? Log t का 1 upon t, and then again this t का हमें differentiate करना है, right? And differentiate हम किससे कर रहे हैं? हम x से कर रहे हैं. So then again del x of t. But what is t? T is x plus r.
Okay, ma'am.
Yes. Now next we want del square z
Ma'am,
del x. हाँ बोलो.
ma'am, in the right side of the second step, you multiplied x upon x plus r into 1 and x upon x plus r into x by r.
No, I didn't do that. I simplified it. 1 plus x by r. So if you
Acha.
take r common, so then r LCM, then you will get your x plus r. Isn't it? R plus x is same as x
Okay,
plus
fine. You
x, right?
just added the bracket. Okay.
Yes. Okay. Now again differentiating this with respect to x. So then what we will get? 1 upon x plus r into again differentiating this x plus r with respect to x. So that means 1 plus del r del x. Now substituting the value, so x plus r, and then we will get 1 plus x by r. So basically it's the same. So 1 by x plus r into r, and then x plus r. So x plus r is gone, so we have 1 by r. So now we have found a del square z del x square is nothing but what? 1 by r. Now we will go for y के लिए. Okay. So now next we will find del z del y. So we have to go from the first differentiation. So now next we will find del z del y. So while we'll differentiating z with respect to y, x will behave as a constant because x and y are both independent variables. So therefore here x will behave as a constant and again log function. So we'll get 1 upon x plus r, but then we will x when you are differentiating with respect to y, so that will be 0 plus r with respect to y, that we will get. So del r del y minus r, so that we will get is del r del y. See, is this clear? So therefore, now what we
मैम
will
इधर
get,
ऐड करना चाहिए ना?
क्या del z del y
इधर सेपरेट क्यों किया मैम?
तो
del r by del y.
ये है ना माइनस आर है ना, जो z मिला हमें, जो हमारे साथ z है, तो वो z को ही हम लोगों ने डिफरेंशिएट किया विथ रिस्पेक्ट टू y. बट व्हेन वी आर डिफरेंशिएटिंग z विथ रिस्पेक्ट टू y, तो ये x विल बिहेव एज अ कांस्टेंट, isn't it? क्योंकि x तो इंडिपेंडेंट है, x एंड y बोथ आर इंडिपेंडेंट. So therefore, ये x का x ही रहा, then log of x plus r का 1/x plus r हो गया. Then x plus r को जब हम लोगों ने y से डिफरेंशिएट किया, so the first one becomes 0 because it is x plus del r del y, and then minus r है, तो वो r तो function of y है, right? So that means that we can differentiate with respect to y. Now what is del r del y?
मैम ये
Del r
कैसा
del y
होता है माइनस r?
कौन सा नहीं समझा?
ये माइनस वाला नहीं समझा पार्ट. माइनस del r by del y.
ये z क्या है आपके पास? z में एक माइनस r है ना पीछे.
हाँ हाँ
r
बिल्कुल.
तो कांस्टेंट नहीं है, r इज अ फंक्शन ऑफ x एंड y, तो r को तो हम डिफरेंशिएट कर ही सकते हैं y से, isn't it? Are you getting?
यस यस है मैम गलत.
Ma'am,
So,
but फिर वो minus del r by del y, where does it go?
where does it go मतलब? इधर ही तो है.
No, in the above scene, a minus del r by del x, you just changed it to minus x by r.
देखो ये del r del x का वैल्यू हमने फाइंड किया है ना,
Oh, okay.
तो वही वैल्यू लिखा है del r del x में. अब del r del y का भी वैल्यू फाइंड किया है पहले से, y अपॉन r, तो हम del r del y तो नहीं लिख सकते, उसका वैल्यू लिखना पड़ेगा ना, तो इसीलिए y by r लिखा है.
Okay, ma'am.
So now what we can do, we can take, हाँ बोलो.
Ma'am, so we can't write del z del y in a similar way to del z del x because उसमें that x factor is there, no?
Yes, yes, yes. That's why here you can see z is not, symmetric. Whereas in the previous case, if you consider u is f of r लिखा है, वहाँ
Yes.
पे x, y, z कुछ भी नहीं है, तो u equal to f of r था, और यहाँ पे भी r square is this. तो यहाँ पे हम लिख सकते हैं, क्योंकि जो भी हम x से डिफरेंशिएट करेंगे, तो वही हम y से और z से भी हमें वही सेम आंसर मिलेगा. ओनली डिफरेंस विल बी x के बदले में y मिलेगा, राइट? बिकॉज देन देयर इज नो x y z विथ f of r, पर यहाँ पे x है, पर यहाँ पे y नहीं है, राइट? सो दैट मीन्स हियर इट विल बी डिफरेंट, इट कांट बी सिमिलर. जबकि r स्क्वायर इक्वल टू x स्क्वायर प्लस y स्क्वायर, वहां पे सिमेट्री है, तो वहां पे हम इसीलिए del r del x फाइंड करने के बाद del r del y सेम वे लिख सकते हैं. बट यहाँ पे हम del y सेम वे नहीं लिख सकते. Okay. So now what we will get, x upon x plus r minus 1. So let us simplify this. Then we'll get x plus r, and here we will get x minus r. So this x and x got cancelled, this r and r got cancelled. So we have minus y by x plus r. So ये हो गया हमारा del z del y. So now we will find del square z del y square. अब इसमें भी जब x है, this x is constant, rest all are function of y when we are differentiating with respect to y. So let us apply u by v rule. So we'll get x plus r whole square, then x plus r into y with respect to y. So that is 1 minus y into now x plus r with respect to y. So सबसे पहले x के लिए हो गया हमारा 0, and then r with respect to y. So del r del y. See, is this clear? Then minus, here we will get x plus r whole square. So here x plus r minus, so y into, now this is 0, and del r del y is what? Y upon. Okay. Now this is equal to minus, this r we can bring down, Then we will get here r into x plus r whole square. Then this x plus r will be multiplied with r. So we will get xr plus r square minus y square. But r square minus y square is what? X square. Isn't it? From here, r square minus y square is x square. So we can write now x plus r whole square, xr plus x square. So then we can take x common now. So if we take x common, we will get r plus x divided by r into x plus r y square. So what we will have now? 8x plus r will get cancelled. Yeah. So 1x plus r will be cancelled. So minus x upon r into x plus r. Now this is what? This is my del square z, del y square. Now I'm going to add these two because I have to add these two. So now let us add these two. And then let us see what we will. Okay, so now coming to the left hand side, so which is equal to del square z del x square plus del square z del y square, which is equal to 1 upon r minus x by r into x plus r. So now let us take common. So r into x plus r LCM ले लेते हैं और फिर यहाँ पे मिल जाएगा x plus r minus x. So x and x gone, r and r gone. So we have 1 upon x plus r, which is equal to. Is this clear?
Yes, ma'am.
And this is also one of the important questions that's coming in. Okay, so then next we will find out if u is equal to f of x square plus 2y square, comma y square plus 2z. That is, u is a function of x square plus 2y square and y square plus 2z. Then prove that y square minus zx into del u del x plus x square minus yz into del u del y plus z square minus xy into del u del z is equal to. Okay?
Ma'am, what is it? X square plus y square, comma or plus?
X square plus 2y square, comma y square plus 2z. So that means u is a function of this and this. Okay. Now instead of considering the whole thing, what we can do, so let us say let p is equal to x square plus 2y square and q is equal to y square plus 2zx. Then what will happen? My u will be, I can write then u as f of p comma q. Whereas my p and q both are what? Functions of x, y, and z. So now I can draw tree diagram. Okay? Because I should be able to draw the tree diagram. So now u is a function of p and q, and p and q are functions of x, y, and z. So p, q are functions of x, p and q are functions of y, and P and Q are function of x. That means U is a composite function. So U is a composite function of x, y and ये इंटरमीडिएट जो वेरिएबल है तो ये जो है ये अगर इसका फंक्शन है एक्स वाई जेड तीनों का ही होना चाहिए नीचे जितने भी वेरिएबल्स है सबका फंक्शन होना चाहिए देन we can say that u is a composite function of x, y, z. Right? So once we know that u is a composite function of x, y, z, then without going to the question, what we need to find. So we know that we can easily find del u del x, okay? Then we can find del u del y, and we can find del u del z. Right? So what will be my del u del x? So I have to consider all the possible paths that lead to x. So it will be del u del p, then p with respect to x plus del u del q, and then q with respect to x. So which is equal to now del u del p, because we have said u is a function of pq. But what is that function? We don't know. So therefore, we will keep it as del u del p. But del p del x, that we can find because we know p is equal to x square plus 2y square. So del p del x is equal to what? 2x plus del u del q. Same way, del u del q we don't know, so we will keep it as it is. And del q del x. So del q del x we will be getting as what? 2z. Right? Next what we will get? Del u del y. So del u del y is del u del p and then p with respect to y, u with respect to q, and then q with respect to y. So here we will get again del u del p, which we don't know, so we are leaving it as it is, and del p del y. So del p del y is what? 4y plus del u del q into what is del q del y? Del q del y is 2y. Similarly, we will get del u del p, then p with respect to z plus u with respect to q, and then q with respect to z. So del u del p into, now what is del p del z? There is no z term there, so that means it is 0 plus del u del q into q with respect to z. So that is what? 2x. Now once we have find this, now we will see what is given, or this del u del x, del u del y, del u del z, where exactly these are. So you have to consider left hand side. Now simply multiply by the given coefficients and see whether we get. So therefore, left hand side is y square minus zx into, let us write this person, del u del x plus x square minus yz into del u del y plus z square minus xy into del u del z. Now, instead of multiplying everything together, so you can see this ultimately you have to add, right? So del u del p is common. So let us take del u del p. And then you multiply the coefficients with the other. So what we will get then? 2x into, so 2xy square minus 4x square from here. Next, from here what we will get? Sorry. This is not, this is z. This is z. And this is 2. So we will get here as 2z x square or 2x square. Okay. Next, what we will get? X square minus yz is this. So 4x square y minus 4y square is z. Okay. Then with this I have 0. So this is with del u del p. Now next I have del u del p. So let me take common del u del q, and then again 2z into this. So we'll get here 2y square z minus z square 2z square x. Then with this 2y into this, so plus 2x square y minus 2y square z, and then we'll have plus 2x z square minus 2x square y. Okay, so now you can see 4x. Oh, you have again. Yeah, correct. So del u del x. Come as 0. Just see if I missed something. Because here it is coming 2y square z, 2y square z, 2x square y minus 2x square y, and 2x z square, 2x z square. This is coming as 0. What about here? 4y square z. Yes. Question was wrong here. So this should be x square plus 2yz. Written wrong. X square plus 2yz. So therefore here it will be x square plus 2yz. So if it is 2yz, then this is same. Now for y we will get 2z. Here we will be getting 2z. Just do the changes. 2z. And del u del z में del p del z will be 2y. So this will change. So y square minus zx, so 2xy square minus 2x square z. Then इसके लिए आ जाएगा, we have 2z. So 2z, that means plus 2x square z minus 2y z square, and next के लिए आ जाएगा z 2z square y minus 2x y. Now I think it will come. Yeah. So minus and then 2x square z and 2. So finally it comes out to be 0, which is equal to right. So just change this first. So it should be x square plus 2yz and y square plus 2z. I hope all of you have got this. Now, next, given if f of u comma v is equal to 0, where u is equal to lx plus my plus nz and v is equal to x square plus y square plus z square, that prove that Lx minus Ly minus Mx plus Ny minus Mz, then we have del Z del x plus Lz minus Nx into del Z del y is equal to, this is little interesting. First of all, what you have to prove, there f is not there. Okay. Secondly, what you have del Z del x and you have del Z del y. So what you have to prove from there, you need to understand that here Z is a function of x and y. Although we have written here u, v as in terms of x, y, z. So u and v both are functions of x, y, z, but z is again function of x and y. So it means that z is not here an independent variable. Z is depending on x and y. Okay. So let's try to draw the tree diagram here. So the tree diagram will be what? First of all, f is a function of u and v. That's for sure. Okay. And then u, v, they are functions of x, y, and z. But again, there is a function of x and y. So ultimately, u and v, at the end, we have u and v. They are also functions of x, y. Okay. So that means what we have finally, that f is a composite function of only x and y, not x, y, z. Okay. And that we have understood from the given question. Is it clear? This is very, very important. So that's why I said that here, from the question you can find out that actually which is the function of what. Okay. So now we can find that what we can find now that f is a composite function of x and y. So we can easily find now del f del x and del f del y. So let us try to do that. So del f del x. What will be del f del x? Del f del x will be del f del u, then u with respect to x plus del f del v, and then v with respect to x. So what we will get then? F with respect to u. Now u with respect to x. So this u we are differentiating with respect to x. And here what happens that x and y are independent of each other. That means when you differentiate x with respect to y or any y with respect to x, that will be equal to 0. But when you differentiate z with respect to x, then you will get this term del z del x, because z is a function of x and y. So here what we will get del u bolo.
Ma'am, but in the question they've not asked for del f del x, then why are we finding that?
Because from the tree diagram, okay, so from the tree diagram, we know that we can find del f del x and del f del y. तो शुरुआत कहीं से तो करनी है ना, तो कहाँ से करनी है जो हमें पता है वहीं से हम करेंगे. So from the tree diagram, it is clear that f is a composite function of x and y, and if f is a composite function of x and y, then we can find del f del x and del f del y. ये हमें पता है कि हमें क्या फाइंड कर सकते हैं. तो जो हम फाइंड कर सकते हैं फ्रॉम द ट्री डायग्राम, तो हम वही पहले फाइंड करेंगे एंड देन वी विल सी कि हम क्वेश्चन तक कैसे पहुंचे.
Okay, ma'am.
Okay, because if you notice, in all questions we have done the same thing again and again. In all questions, जैसे हमें पता चलता है कि यहाँ पे suppose u is a composite function of x, y, z. So without looking into question, हमने पहले क्या find किया? कि del u del x हम फाइंड कर सकते हैं, राइट. सिमिलरली del u del y एंड del u del z ये हमें पता है कि हम फाइंड कर सकते हैं, इसीलिए हमने पहले से del u del x फाइंड किया. Similarly, if you go for this one also, so we know that phi is a composite function of u v w. So therefore, we have evaluated first del phi del u del phi del v del phi del w. के बाद हमने क्वेश्चन देखा, करेक्ट, कि हमें क्या चाहिए. But first of all, when you see the question, you can see that phi is a function of x y z, okay, and phi is also function of u v w. तो ये आपके ऊपर है कि आप किस तरह से उसको लिखना चाहते हो. Whether f phi is a composite function of u v w or phi is a composite function of x y z. आप दोनों तरह से लिख सकते हो. अगर phi is a composite function of x y z लिखना है, इसका मतलब इंटरमीडिएट में क्या आना चाहिए, इन बिटवीन u v w आना चाहिए. मतलब u v w should be function of x y z. इसका मतलब जो दिया है उसको आपको u v w फाइंड करना है इन टर्म्स ऑफ x y z. आप दोनों तरह से आप उसको देख सकते हैं, लेकिन जिस तरह से हम ट्री डायग्राम बनाएंगे उस तरह से हम उसको फाइंड करेंगे. ओके, सो वी कैन ऑलवेज फाइंड आउट phi if we are considering as composite function of u v w, that means we can easily find del phi del u del phi del v del phi del w. So the same way यहाँ पे we have drawn the tree diagram and we saw that f is a function of x and y. So at least we know that we can find del phi del x and we can find del f del x and we can find del f del y. इतना तो हमें पता है कि हम इसका फाइंड कर सकते हैं. तो जो हम फाइंड कर सकते हैं वो हम पहले फाइंड कर लेते हैं. After that we will see what else information we need to incorporate here. Hope this is clear.
Yes, ma'am.
So now del u del x. So del u del x will be what? Lx. So if you're differentiating that with respect to x, so we will get L. Then my. Now for my with respect to x will be 0. And then for nz, that we will get what? N into del z. Because z is a function of x and y. And that we know from the given question, because there it is given del z del x term and del z del y term. So when these two terms are there, so we need to understand that here z is considered as a function of x and y. Similarly, here we can write now del f del v. Now del v del x. So del v del x will be what? 2x plus, again z square is there, so it will be 2z del z del x. So this is what? Del f del x. Similarly, del f del y we can find. So let us find that del f del u and then u with respect to y plus f with respect to v and then v with respect to y. So this will give us del f del u into del u del y. So what is del u del y? It will be m plus n into del z del y plus del f del v into v with respect to y. So it will be 2y plus 2z into del z del y. So from the tree diagram ये हमें मिलता है. So that now we have written. अब हम क्वेश्चन देखेंगे. सबसे पहले क्वेश्चन में क्या है? That f is equal to 0. If f is equal to 0, that means my del f del x and del f del y will be equal to 0. So now let us use the first information that we have. So now f is equal to 0. So if f is equal to 0, this implies my del f del x is equal to 0 and del f del y is equal to 0. What does it mean? So therefore what we can say that my right hand side del f del u into L plus n del z del x plus del f del v into 2x plus 2z del z del x is equal to 0. Similarly, del f del u into m plus n del z del y plus del f del v into 2y plus 2z del z del y is equal to 0. See, is this clear?
Yes, ma'am.
Now we will see what we want. So what we want, okay, what we don't want from this del f del u and del f del v. क्योंकि क्वेश्चन में कहीं पे भी del f del u नहीं. So that means we don't want del f del u and del f del v. So if we don't want del f del u and del f del v, that means we need to eliminate them. So what is the easy way to eliminate? दोनों equations से del f del u upon del f del v we can easily evaluate, and since f is the same function, so मेरा del f del u upon del f del v will be same for both. So what I can find now, or the other way, मतलब जैसे भी आपको find करना है, तो कोई भी एक just ratio आप find कर लो. So del f del u upon del f del v will be equal to what? So this is my minus 2x plus 2z del z del x upon L plus n del z del x, right? So this is equal to minus of this, so ये इधर आ गया, फिर ये नीचे चला गया. So we'll get minus 2x plus 2z del z del x upon L plus n into del z del x. Similarly, from, so let me say 1 implies, so 1 and 2. So 2 will imply what? 2 से हमें मिलेगा same del f del u upon del f del v will be equal to what? Minus, here we will get 2y plus 2z del z del y upon m plus n del z del y. Now, दोनों रेशियो सेम है, इसका मतलब ये दोनों भी सेम होना चाहिए. So therefore, now let us equate both and see what we get. So therefore, what we will get, so minus minus cancel, so 2x plus 2z del z del x upon L plus n into del z del x is equal to 2y plus 2z del z del y upon m plus n into del z del y. So यहाँ से मेरा 2, 2, 2. Now what I want to do, so del z del x, right? So basically I need to take the coefficients from del z del x and del z del y. So now let me multiply. So x plus z del z del x into m plus n del z del y. Okay, and this side I will be getting minus or equal to y plus z into del z del y into L plus n del z del x. अभी दोनों साइड खोल दो. What we will get if we simplify, so which implies x into m. So let me write as mx plus nx del z del y plus mz del z del x plus nz del z del x into del z del y, which is equal to, ये भी equal to, so y into L plus yn del z del x plus zl del z del y plus nz del z del y into del z del x. Now if you see, ये दोनों terms same है, so these two terms will get cancelled. अब coefficients को साथ में लिख देते हैं, so which implies, let me first write for del z, let me write for this. अब यहाँ पे minus m है, ये पूरा साइड यहाँ पे लेके आते हैं, so we will get L into y minus mx. So the first term we have got. Next del z del x का coefficient देख लेते हैं, so del z del x का coefficient we have, ये पूरा का पूरा साइड हम यहाँ पे लेके आ रहे हैं, so n into y, okay, minus m into z del x. Next del z del y का L into z minus n into x del z del y, which is equal to 0. So this is what we wanted to
मैम del f by del u ये 0 नहीं होगा।
Pardon?
del f by del u 0 नहीं होगा।
del f del u हमने इवेलुएट किया ना, del f del u अपॉन del f del v, क्योंकि हमें वो चाहिए नहीं ना। क्वेश्चन हम एक एक करके देख रहे थे। इन दिस क्वेश्चन वी डोंट वांट del f del u or del f del v. So when we don't want them, so that means we need to eliminate. So to eliminate, what we have found this ratio del f del u upon del f del v. So from 1 and 2 we found del f del u upon del f del v. But then left hand side is same, isn't it? There's the same ratio. So that means the two values also should be same. So hence equative right hand side from both the ratios. So then just simplify. अब बस खोल ही रहे थे. Simplifying, and then finally we just take in del z del x and del z del y. So we have finally got this, and this is what we wanted to show.
Ma'am,
हाँ बोलो.
ma'am, if f of uv is equal to 0 and we've written del f del x is 0, then even del f del u and del f del v will be 0 now.
No. See, यहाँ से हमें क्या मिला है? F is a function of uv, but then uv in turn function of finally what? X and y only, na?
Yes, ma'am.
So ultimately you are differentiating f with respect to x and y. So therefore at the end आपने इसको किससे मतलब differentiate किया? F finally becomes a function of what? X and y. So अगर आपका f 0 है तो फिर del f del x 0 आएगा and del f del y 0 होगा, क्योंकि हम जो differentiate कर रहे हैं वो f with respect to x कर रहे हैं या f with respect to y. At the end basically यही है ना, f is basically depending on x and y only. तो
Yes, ma'am.
uv जो है वो uv basically इसका u and v are functions of x and y. So we don't want to complicate the function. Therefore we just written given a name of the variable. So that is first we are considering as uv and then we are considering as x and y. तो इसलिए जो composite function होगा f, मतलब वो फंक्शन जिसका कॉम्पोजिट फंक्शन होगा उसी का डेरिवेटिव 0 होगा. इंटरमीडिएट डेरिवेटिव 0 नहीं होगा.
Okay, ma'am.
तो इसलिए राइट हैंड साइड मतलब हर एक डेरिवेटिव 0 नहीं हो सकता, बिकॉज दिस इज 0, बट दैट डजंट मीन कि del f del u भी 0 होगा, del f del v भी 0 होगा, सब 0 होगा, ऐसा नहीं है, जरूरी नहीं है. Because we are considering this rate of change with respect to x, not with respect to u. दोनों अलग होगा ना.
Yes, ma'am.
So these type of problems are a little you can say tricky, because you also have to see कि वो function finally कौन से variable independent है. Let's try another question. Next is given x is equal to p cos theta minus q sin theta and y is equal to p sin theta plus q cos theta. Okay? And u is a function of x and y. Then prove that we want to show del square u del x square plus del square u del y square is equal to del square u del p square plus del square u del. Okay. So this is basically second order. So x is function of okay, now from here you can see x is a function of what? You can see here you have u is a function of x and y, and u is a function of p and q. So ultimately, u is a function of x and y, and x is a function of p and q. That is how we can consider. So let us write. So u is a function of x and y. ये हमारे पास दिया हुआ है. And from here we can see x and y are functions of p and q. So therefore we can say that u is a composite function of p and q. That means we can easily find del u del p and del u del q.
Ma'am,
बोलो.
ma'am, won't theta also be a variable?
So obviously theta will be constant. नहीं तो अगर थीटा कांस्टेंट नहीं होता तो फिर वहां पे विथ रेस्पेक्ट टू थीटा उसको आ जाता ना.
Okay, ma'am.
तो नहीं है इसका मतलब थीटा इज कांस्टेंट. दैट वी नीड टू अंडरस्टैंड. ओके, सो del u del p now we can find. Okay, so del u del p will be what? My del u del x, then del x del p plus del u del y, and then y with respect to p. So del u del x हमें पता नहीं है, so let me write as del u del x. Now what is del x del p? So del x del p is cos theta plus del u del y, and then y with respect to p, that is sin theta. Now similarly, del u del q, we will be getting del u del x, then x with respect to q plus u with respect to y, and then y with respect to q. So del q del x into, I think with the same one, similar type of substitute transformation we might have done for the first order previously, one question. So next, del u del x into del x del q. So del x del q is minus sin theta plus del u del y into del u del y del q. So that is my cos theta. Okay. Now we want to find second order. So obviously we will go for first del square u del p. Now let us see what we will get. So this means what? Del del p of del u del p. Okay. So what is my del del p of del u del p? So del u del p is cos theta into del u del x, because this is constant, so I'm writing it plus sin theta into del u del. Okay, now let's see here. Okay, so now cos theta जो है, ये cos theta तो constant है, तो cos theta बाहर आ गया. ठीक है. So what we will get now, del del p of del u del x, और यहाँ पे हमें मिला sin theta into del del p of del u del y. Now the question is, what will be this del u del x with respect to p? वो क्या होगा? Yes, tell me what you think. Del u del x with respect to p.
Del square u del p del x.
Del square u del p del x. कैसे?
No, like del square u.
P
Okay.
and x are not, because x depends on p, isn't it? See here.
Yes, ma'am.
X depends on p and q both. X, y both depends on p and q. So let's first consider this one. So फिर easily ये क्या होगा हम पता कर सकते हैं. Anyone else? Yes, del u del x with respect to p हमें find करना है. So obviously x is a function of p, that we need to consider, right? So partial differentiation तो आएगा.
Ma'am, we can write del u del. No, sorry.
And any other? You see who all are present. चिराग बोलो क्या हो सकता है आपको क्या लगता है इट मे बी रॉन्ग दैट डजंट मैटर बट एटलीस्ट यू नो आप लोग सोचोगे तो सही चिराग प्रेजेंट यहाँ पे तो दिखा रहा है प्रेजेंट यस आप हो नहीं हो तो फ्रॉम हियर मींस आई कैन मेक आउट राइट कि आप लोग बस लॉग इन करके बैठे हुए हो कि ईशा
Yes, ma'am.
हाँ बोलो आपको क्या लगता है क्या हो सकता है यस मनन प्रेजेंट
Yes, ma'am.
हाँ बोलो आपको क्या लगता है क्या हो सकता है
Ma'am, can you repeat the question once again, please?
तो आई सेड व्हाट विल बी द बेसिकली यहाँ पे आंसर क्या आने वाला है वही मुझे चाहिए डेल यू डेल एक्स को अगर हम p से डिफरेंशिएट करेंगे तो क्या आएगा इसमें हम क्या लिखेंगे you can tell me in terms of this you know like instead of telling me the values you can also tell me in terms of you know del square u ऐसे भी बोल सकते हो that is also fine कौन सा बेसिकली यहाँ पे क्या आने वाला है मतलब कैसे हम इसको
Ma'am,
डिफरेंशिएट
chain rule लगा सकते हैं?
ऑब्वियसली तो कैसे चेन रूल लगाएंगे
Ma'am,
बस इतना ख्याल रखना है कि x इज अ फंक्शन ऑफ p so that means if we are using chain rule so obviously x को हम p से डिफरेंशिएट करेंगे बाद में राइट बिकॉज अल्टीमेटली डिफरेंशिएट हमें करना है p से अच्छा एक बात बताओ ये डेल यू डेल एक्स जो है इसको अगर हम मान लेते हैं डेल यू डेल एक्स इज सपोज सम फंक्शन g तो ये किसका फंक्शन होगा डेल यू डेल एक्स ये किसका फंक्शन होगा
x
ओनली एक्स पार्शियल डेरिवेटिव ना तो पार्शियल है तो एक अकेला तो हो नहीं सकता है
X and Y.
x and y correct so del u del x will be a function of x and y both आप बता सकते हो so now del p of del u del x is nothing but what del p of g isn't it or you can say del g del p so what is del g del p then p is a function of x and y and we want to differentiate now g with respect to p correct देखो कभी भी पार्शियल डेरिवेटिव करना है तो सबसे पहले हम क्या यूज करते हैं ट्री डायग्राम ड्रॉ करते हैं राइट so can you draw the tree diagram for g so are you able to draw the tree diagram for g all of you please try
It will be similar to the U wala T diagram that you have drawn, no?
यस यस यस, ट्री डायग्राम मतलब ऐसा डायग्राम तो एक ट्री दिखाते हैं, ट्री की
हाँ,
तरह
I'm
लगता है
saying without,
branches से.
in place of u, if you put g, that will be the tree diagram, no?
Yes, yes, yes. So g is a function of x and y, and x and y are function of p and q. ये तो पहले से ही है हमारे पास, राइट? तो पहले हमारे पास फंक्शन क्या था? u. अब हमारा फंक्शन क्या बन गया है? g. u और g, u and g are similar क्योंकि u भी हमारा फंक्शन ऑफ x y है, g is also function of x and y. तो फिर g also become composite function of p and q. So that means we can easily now find del g del p and del g del q. Yes. So what will be del g del p?
It will be del g upon del x into del x del p plus
Correct.
del g upon del y into del y del p.
Correct. अब g क्या है? g हमारा del u del x है, राइट? सो g को हम del u del x बना देते हैं तो क्या हो जाएगा? del del x of del u del x, that means it is what? Del square u del x square into del x del p. Del x del p हमें पता है क्या है, राइट? So del x del p is cos theta. So this is cos theta plus del g del y. Now g is what? Del u del x. So del u del x को आप del del y से differentiate कर रहे हो. So we will get what? Mixed partial derivative del square u del y del x into del y del p, and del y del p is what? Sin theta. So is this clear now?
No, ma'am. Ma'am, I didn't understand. How did you write del u del x as g of xy?
What? Del g?
Del u del x is equal to g of x and y. I didn't get that part.
अच्छा, del u del x वो क्या है? किसका फंक्शन होगा? उतना बताओ. u हमें पता है, राइट? u इज अ फंक्शन ऑफ x एंड y. वो तो हमें ट्री डायग्राम से दिख ही रहा है. अगर हम u को विथ रिस्पेक्ट टू x डिफरेंशिएट करते हैं तो वो किसका फंक्शन बनेगा?
X and y.
x एंड y का ही फंक्शन बनेगा. सो
Yes.
we can write that del u del x वो x and y का ही फंक्शन बनेगा. मतलब we can write as say some g of x and y.
Yes, ma'am.
करेक्ट? तो फिर हमारे पास अभी तो दैट मीन्स व्हाट वी हैव गॉट नाउ, g इज अ फंक्शन ऑफ x एंड y. और हमें पहले से ही पता है कि x एंड y बोथ आर फंक्शंस ऑफ p एंड q. तो हम g के लिए ट्री डायग्राम बना सकते. ट्री डायग्राम क्यों बनाते हैं? सो दैट वी नो जो हम कैसे हमें डिफरेंशिएट करना है, किसके साथ हमें डिफरेंशिएट करना है, और वो चेन रूल में कैसे आएगा, क्या क्या पाथ हमें कंसिडर करना है. इसके लिए हम ट्री डायग्राम बनाते हैं, राइट? तो ट्री डायग्राम गिव्स अस अ क्लियर पिक्चर ऑफ by which variable we need to differentiate what. So here we have to differentiate u with respect to p as well as q, क्योंकि u becomes composite function of p and q. तो जब हम differentiate करेंगे u को p के साथ तो हमें कौन सा पाथ लेना है, क्योंकि बीच में x y भी है. तो ये हमें ट्री डायग्राम बताते हैं कि किस तरह से हमें पाथ कंसिडर करना है. तो सेम वे बिकॉज वी हैव योर del u del x और यहाँ पे p था तो हमें थोड़ा कंफ्यूजन लगा कि अब ये क्या होगा. बट तो हमें ये del u del x किस टाइप का फंक्शन बनेगा वो पहले जानना है. सो del u del x वी नो दैट इट विल बी अ फंक्शन ऑफ x एंड y. तो उसको हम del u del x ना लिख के सम g नेम कर देते हैं, ठीक है? सो दैट मीन्स नाउ g इज नथिंग बट अवर del u del x. So this is a function of x and y are function of p and q. That means ये जो हमारा del u del x और g है वो क्या हो गया? Composite function of x and p and q. अगर ये composite function of p and q है, इसका मतलब हमें पता है कि हम इसको p and q से differentiate कर सकते हैं. अगर differentiate कर सकते हैं तो फिर path कौन सा consider करना है? What path we need to consider? That also it is clear from the tree diagram. So therefore del G del P will be equal to what? मैं ये del U del X बार बार यहाँ पे नहीं लिख रही हूँ so that confusion ना. So del G del P will be what? G with respect to X, X with respect to P, that is what we have written, plus G with respect to Y and Y with respect to P. Is this clear? ये same है, exactly same है. Okay. Now what will be del G del X? अपना G क्या है? G तो del U del X है, right? So what is my del G del X then? Del G del X is equal to del X of G. But what is G? G is del U del X. So that is equal to what? Del square U del X square. So therefore I have written here for del G del X I have written del square U del X square. और del X del P जो है वो तो पहले से ही पता है हमें, right? So del X del P is equal to cos theta. Similarly del G del Y. What will be del G del Y? So del G del Y means del Y of G. But G means what? Del U del X. But del U del X is function of X and Y both. इसके लिए del U del X को हम Y से differentiate कर सकते हैं. So it will be what? Del U del Y del X. Mixed order partial derivative will come. Is this clear now?
Yes, ma'am, I got it. Thank you.
Okay. So now then what we will get? So now what we can do? So now we can write. Okay. So now let us come to our this. Okay. So what we have got del square U del P square is equal to, let me start from here. So cos theta into, now del P of del U del X, what I can write? So it will be basically my del square U del X square into del X del P plus del square U del Y del X into del Y del P. Is this clear? Okay. So you draw this tree diagram and then it will be clear. Next what I have with that del square U del P square के साथ, अच्छा ये तो मैंने पहला वाला ही किया, अभी दूसरा वाला भी बाकी है, राइट? प्लस साइन थीटा इनटू, नाउ नेक्स्ट व्हाट आई हैव del P of del U del Y. अब just replace del U del X by del U del Y. ये थ्री डायग्राम सेम ही रहेगा क्योंकि del U del Y भी तो del U del Y is also function of X and Y and X and Y are functions of P and Q. तो del U del Y के लिए भी ट्री डायग्राम वही रहेगा, करेक्ट? So del U del Y is also composite function of P and Q. So now we know the path. और हमें Y से डिफरेंशिएट करना है, मतलब सॉरी Q से डिफरेंशिएट, नो P से डिफरेंशिएट करना है. तो P के लिए भी वही सेम पाथ ही आएगा. That means first we will differentiate with respect to X. So let me write del X of del U del Y into X with respect to P. So X with respect to P plus next with respect to Y. So del Y of del U del Y and then Y with respect to P. So Y with respect to P. So this is what we will be getting. Is this clear? जैसे एक नया फंक्शन आ जाता है तो हमेशा उसके लिए ऐसा जरूरी नहीं है कि आप एक ही बार खाली ट्री डायग्राम बना लोगे और उसमें से ही सब आ जाए. But then in case if you get any new function, तो उसके लिए भी आपको वापस से ट्री डायग्राम बना के देखना है कि वो कैसा फॉलो हो रहा है, वो कौन सा पाथ फॉलो कर रहा है. Okay, so cos theta into, now what about this del square U del X square? We don't know the value, so let me write as del square U del X square. Now del X del P I know, so del X del P is cos theta plus del square U, अब del square U del Y del X is same as del square U del X del Y. Okay, जब तक discontinuity ना हो तब तक ये same ही रहेगा. Then we have del Y del P. So del Y del P is sin theta plus next इसमें आ जाएगा sin theta into, now this one will be del square u del x del y, del x del p is again cos theta plus del square u del y square into del y del p. So del y del p is sin, del y del, yeah, is sin theta. Okay, so you can see यहाँ पे ये दो टर्म आ रहा है सेम सेम, so that is what cos theta sin theta is, sin theta cos theta into. Fine. So if we simplify now, so what we will get, we can write this as cos square theta into del square u del x square plus 2 sin theta cos theta into del square u del x del y plus sin square theta into del square u del y. Up same way, we need to find del square u del u square. Okay, so let us find del square u del q. तो अपने पास del u del q है. So with respect to q, now we have to find. So what we will get, minus sin theta del q of del u del x plus cos theta into del q of del u del. तो ऑलरेडी हमने ट्री डायग्राम ड्रॉ करके रखा है, पहले हमने p के लिए देखा, अब हमें q के लिए देखना है. So it will be same way we can find out. So then what we will get, so minus sin theta into, अब ये आसान है राइट, del u del x with respect to q. तो फर्स्ट हम डिफरेंशिएट करेंगे with respect to x, del u del x with respect to x into del x del q plus नेक्स्ट y के लिए भी चाहिए हमें, so del y से हम डिफरेंशिएट करेंगे del u del x को and then y with respect to, ये हो गया फर्स्ट. नेक्स्ट वी हैव प्लस cos theta into, तो del u del y. अब इसके लिए आते हैं, तो इसके लिए क्या हो जाएगा, सेम वे, तो पहले हम x से डिफरेंशिएट करेंगे, तो del u del y into then x with respect to q plus y से डिफरेंशिएट करेंगे del u del y and then y with respect to q. Okay. Now simply we will substitute the value. So minus sin theta into, this will be del square u del x square. Now del x del q, so del x del q is minus sin theta plus del square u del y del x into del y del q is cos theta plus cos theta into, so this one will be del square u del x del y, del x del q is minus sin theta, and here we will get del square u del y square and del y del q is cos theta. So same way, now if you just multiply, so we will get sin square theta del square u del x square, यहाँ पे minus sin theta cos theta, यहाँ पे भी minus sin theta cos theta, मतलब minus 2 sin theta cos theta del square u del x del y and plus cos square theta del square u del y. अब दोनों को ऐड कर दो, तो 2 sin theta cos theta minus 2 sin theta cos theta वो कैंसिल हो जाएगा, then cos square theta plus sin square theta, so you will get only del square u del x square. Similarly, sin square theta plus cos square theta, you will get. Okay, so adding, we will get what? So this will give me, which is equal to del square u del x square sin square theta minus 2 sin theta cos theta del square u del x del y, okay, and plus cos square theta into del square u del y. Now add both, so left hand side will be equal to del square u del x square here to cos square theta plus sin square theta. Next, plus del square u del x del y here. So 2 sin theta cos theta minus 2 sin theta cos theta plus del square u del y square. इसमें आ जाएगा sin square theta plus cos square. So this will go, and then finally you are getting the right hand side. So we need to start from right hand side. क्योंकि P और Q right hand side में है. So we need to start from right hand side, and then we need to substitute, and we will get then left hand. Okay. So this is how you can find out. So in the I'll stop here now, and in the next class what we will do, we'll find another way to find out same differentiation, where you don't have to draw the tree diagram again and again, but we need to consider the operators. So there we will see how we can consider the operator and how does the operator work. Okay, so for finding second order partial derivative, you have two ways to find. One, direct method, that is as it is coming and you draw the tree diagram and you find it out. Or second one is using operators. So later on you can decide whichever way you find it convenient, you find it easier to work with, you can use it. There is no hard and fast rule that you have to use this way or you have to use that way. It's only up to you, whichever way you find it easier. Okay. And as far as the questions are concerned in the exam, so in case if second order questions are there, because it takes time to solve, and if you see that there are other options, then better you keep that and try for other questions. And in case if you can't, then only you go for second order partial derivative, because it will definitely take your time, and also you need to be very, very